scientists just broke the record for the fastest fiber optic data transfer ever. No matter how fast our broadband connections get, it seems like we're always wanting more, and the good news is that more is on the way. A team of engineers has just used a new type of laser-based transmission technology to smash data transfer records, achieving an incredibly speedy 57 gigabits per second at room temperature. That room temperature factor is important, because it shows that the technology could eventually be applied to our homes and offices. Typically, the warmer the temperature, the slower the data transfer. Plus the bits and bytes were beamed without any errors, another significant factor in assessing the technology's mass market viability. To put it in perspective, 57 gigabits per second is enough to download a whole Blu-ray in just a few seconds. That's the fastest ever data transmission speed over a new type of laser called a vertical cavity surface emitting laser, which is used across fiber optic lines, the type of cabling that underpins much of the broadband infrastructure that's already in place in our homes and offices. Our big question has always been, how do you make information transmit faster? Says lead researcher Milton Feng from the University of Illinois, whose team achieved 40 gigabits speeds back in 2014. There is a lot of data out there, but if your data transmission is not fast enough, you cannot use data that's been collected. You cannot use upcoming technologies that use large data streams, like virtual reality, he adds. The direction toward fiber optic communication is going to increase because there's a higher speed data rate, especially over distance. The new VCSEL lasers work by using sharper, more efficient pulses of light. What makes the technology so promising is that it can not only function at room temperature, it can work at higher temperatures too. Speeds of 50 gigabits were recorded at 85 degrees Celsius, and that could be crucial for various industrial purposes, even if your living room never actually gets that hot. Think about the large data centers used by the likes of Amazon and Facebook. Being able to operate these servers without the need for large refrigeration units would be a definite bonus, and a lot less demanding in terms of energy use. That's why data centers are refrigerated and have cooling systems, Feng says. For data centers and for commercial use, you'd like a device not to carry a refrigerator. The device needs to be operational from room temperature all the way up to 85 degrees without spending energy and resources on cooling. The group will be presenting their findings at the Optical Fibre Communication Conference and Exposition in California this week, so until they've had them published in a peer-reviewed journal, we have to remain a little skeptical. And the next challenge will be for the team to demonstrate that they can achieve the same speeds outside a laboratory setting. But what's really exciting here is that while you've probably seen all kinds of reports about record-breaking data transmission speeds in recent months, they cover a wide variety of technologies that would require big infrastructure changes to get them into our homes. The difference with this new speed record is it was achieved with infrastructure similar to what's already in use today, which means this could be something that affects you and your own download speeds sooner rather than later. We can't wait.